In this case, in the case of value encoding, as I told you earlier, so it is used on integer value. This is the integer value. Okay, and this is my original data here. What happens is the value encoding, it transforms this value into this form. If you look at here, almost all the digits are 2 digits, but few values are in single digit. It converted the 3 digit into 2 digit or single digit. How it is possible? What happens here is it takes the minimum value. What is the minimum value in this data set? 194. It's subtracting 194 from each and every value. So 212 minus 194, 18. So if you add 18, what will happen? 212, correct. And 197 minus 194, 3. Likewise, it takes the minimum value from your original column and then subtract the minimum value from each and every value. So this way, what happens is you get, in this case, what happens, the range of the values are, the 0 to 22. So whereas here the range, if you see 194 to, what is the maximum value? 216. So in this case, the X velocity discovered that by subtracting the minimum value, which is nothing but the 194 from all the values of the column, so it could modify the range of the column, right? Reducing it to a range from 0 to 22. Storing numbers up to 22 requires less bits than storing numbers up to 216. So you might be thinking just 216, here 8 bits needed to store the 3 digits, whereas here 2 digits, just 5 bits are needed. You might be thinking 3 bits, how does it make some, how does it, makes so much of difference in terms of performance? Obviously, when you are using billions of rows, right? If you multiply, when you multiply this value, right? 3 bits you saved, right? So 3 bits into few billion records, you can see the difference, right? It will consume less number of storage. It doesn't require too much of space in your hard disk, right? It reduces the space. Using value encoding, this is how the value encoding technique works. This is to reduce the size of the data, okay?